of some other metals. These may be originally present in the ore, unreduced oxide of the metals, non-metals left during the reduction in the furnace. For example, there may be still chances of presence of silicon, carbon or phosphorus. There are still chances of presence of slag, flux taken up from the furnace. So, therefore, further refining of the metal may be carried out depending upon the nature of the metal and the impurities. Some of these methods are follows: liquidation, distillation, oxidation, polling, electro-refining, zone refining, chemical methods. So, it generally depends upon the nature of the metal. The generally alloy is made up from the homogeneous mixture of two or more metals, out of which at least one is essentially a metal. Pure metal are seldom used as engineering materials as they do not possess the required physicochemical and technological properties for some definite purpose. To impact the desired properties, pure metals are alloyed with other metals and non-metals. Some examples of alloys are brass, bronze, cast iron, duro-aluminum. An alloy may be either homogeneous or heterogeneous. Two types of alloys are present. One is ferrous alloy, another is non-ferrous alloy. In ferrous alloy, one of the constituent is iron. In non-ferrous alloy, there is no presence of iron. An alloy of coinage silver is homogeneous. It consists of small crystal grains, each of which is a solid solution of copper and silver. Heterogeneous alloys consist of a mixture of different phases which may be pure metal, one or pure compounds or solutions of metals or their compounds in metals. From the engineering point of view, the alloys are generally known as ferrous alloys and non-ferrous alloys. All alloys available in the world are ferrous or non-ferrous alloys. So, ferrous alloys have one of the constituent, that is iron, and non-ferrous alloys they do not constituent iron. Alloys of iron are known as ferrous alloys when iron is present in the alloys. Iron is used as the essential part in making these alloys. Mild steel, mild steel has carbon from 0.15% to 0.3%. The mild steel is formed by mixing iron with the carbon. Mild steel is used in making boiler plates, steel joints, angles, drop forging. The further is medium carbon steel. The percentage of carbon in medium carbon steel is 0.3 to 0.6%. The medium carbon steel is used in making shafts, high tensile tubes, wires, fish plates, railway wheels, agriculture tools, while high carbon steel, in this the percentage of carbon is more, that is 0.6 to 1.4%. The high carbon steel is used in dies, springs, chisels, woodworking tools, razors, brochures and in drills. So, it is having high percentage of carbon in high carbon steel. The properties of steels determined by dispersion strengthening depend on the amount, size, shape and distribution of the cementite. These factors are controlled by alloying and heat treatment, normalizing, annealing, quenching and tempering. In this, the metal or alloys is heated at high temperature and let them cool normally. So, that is normalizing. And when it is cooled by suddenly, then it is known as annealing. Quenching, when it is heated and then let it cool and then heat it again and then let it cool. This technique is known as quenching. Tempering is keeping the temperature at high for some time and then let it lower at at normally. So, that technique is known as tempering. So, as ferrous alloys, they are mixed with different different types of other metals. With chromium, when it is added up to the 80%, it improves hardness and toughness. So, we will get the chromium blades and the scissors, chromium plated or alloys formed by mixing the iron with chromium. And nickel, when nickel is added to the iron, it improves tensile strength and toughness, and it improves the ductility, elasticity and it heat and cross ion resistance. When iron is mixed with manganese, it increases strength and toughness and it also increases the brittleness. When iron is mixed with vanadium, it increases the tensile strength, ductility and shock resistance. When iron is mixed with molybdenum, it increases the strength at elevated temperature and it cross iron resistance. With tungsten, toughness and shock resistance are increased. When iron is mixed with silicon, the steel strength increases its hardness. It eliminates oxygen and improves resistance from oxygen. So, when silicon is or carbon is used in alloying, the rust free material is obtained. Non-ferrous alloys are metals, participating metals like aluminum, copper, zinc, tin are known as non-ferrous alloys. Iron is not used in making these alloys. Some important non-ferrous alloys are when duraluminum, when copper and zinc are mixed together in 80 to 20% ratio, brasses are formed. When copper and tin are used, then bronzes are formed. The alloys have high electrical and thermal conductivity. Alloys have high good corrosion resistance. Alloys have highly ductile and malleable properties. Alloys can be readily fabricated and they have more life as compared to their parent metals. Alloys can good castability and machinability. Alloys can be easily worked in cold and hot conditions. So, generally alloys are having better properties from their participating metals. Alloys are mostly used in our daily life. Pure metals are not possess the required properties for some definite purpose. So, alloys are made to get required properties. Generally, alloys have good properties from the metals by these are made. For example, some alloys have greater strength more than those metals from which they are made, and some alloys have greater melting points from the metals from which they are made. Due to good strength and hardness, these are mostly used in making homely things, agriculture equipment and industrial machines. Rust free material is also obtained from the alloys. German silver. In German silver, the composition of copper is 20 to 50% and zinc is 10 to 35%, nickel is 5 to 35%. German silver is extremely ductile, malleable and looks like silver. It possesses good strength and corrosion resistance to salt water. German silver is used for making utensils, bolts, screws, cutlery, decorative articles. So, Tobin bronze, it has copper 70%, zinc 29% and tin 1%. It possesses high corrosion and abrasion resistance. This bronze is used for propellers and marine works. In bronzes, copper, tin and zinc are used. The coinage bronze having composition of copper is 89% and tin 11%. It is soft, ductile and durable. It is used for making the coins. Gunmetal, it is having composition of copper, tin and zinc. Copper is 88% while tin is 10%, zinc is 2%. It is hard, tough and strong to resist the forces of explosion. Gunmetal is used for making gun barrels, water fitting, heavy load bearings and parts of high pressure steam plants. Bell metal consists of copper 70% and tin 70%. It is hard, brittle and sonorous, used for making bells. Similarly, nickel bronze, from the name it comes, it is having composition of nickel in it. So, it is used for rolling purpose, valves, general purpose, semi-hard hearings. Materials usually man-made that are a three-dimensional combination of at least two chemically distinct materials with a distinct interface separating the components, created to obtain properties that cannot be achieved by any of the components acting alone. Composites are combination of two materials in which one of the material called the reinforcing phase is in the form of fibers, sheets or particles and is embedded in another materials called the matrix phase. The reinforcing material and the matrix material can be metal, ceramic or polymer. With this, my lecture is over.